Welcome viewers, in this video we will see the solved problem based on the maximum power transfer theorem for a DC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. The maximum power transfer theorem solved problem have DC circuit. The circuit shown below R observe maximum power. Compute the value of R and maximum power. So the circuit is contained 20 ampere current source is available. This is the load resistance. It marked as AB and 3 resistance are available. 5 ohm, 2 ohm and 3 ohm. The condition given is this R is observing maximum power. So we need to find the value of this R and what is the maximum power observed. So the condition is given. The load resistance is observing maximum power. So we can implement the maximum power transfer theorem. What is maximum power transfer theorem? When the load is observed maximum power, the load resistance equal to internal resistance of the circuit. Internal resistance of the circuit is equal to load resistance when the load is observing maximum power. So for that we need to find what is the internal resistance. That should be equal to R value, load resistance. For that we are having the Thevenin equivalent circuit. The Thevenin equivalent circuit is nothing but one voltage source contained in series with the internal resistance. So that it will be very easy for us to go for further process. So the Thevenin equivalent circuit is Thevenin voltage in series with the Thevenin resistance. This Thevenin resistance is nothing but the internal resistance of the circuit. This Thevenin voltage is nothing but when the load terminals are open circuited and find the open circuit voltage, that is V Thevenin. This R Thevenin is nothing but by removing all the voltage and current sources, we need to find what is the internal resistance of the circuit. So in that we can draw this the load resistance R with the terminal AB. So the complicated circuit can be simplified with the Thevenin equivalent circuit. After getting Thevenin equivalent circuit, it is easier. This RTH equal to R. That is the condition of the maximum power transfer theorem. So already given maximum power is transferred, so that this load resistance equal to Thevenin resistance. So by finding this Thevenin equivalent, we can easily equate these two values. Right? So first we will find the Thevenin resistance, V Thevenin. So the 20 ampere source is available. This 5 ohm, 2 ohm and 3 ohm. The load terminal is open circuit. So V Thevenin is nothing but open circuit voltage. Right. So we need to find what is the voltage across VAB. That is nothing but V Thevenin. Here the current source is available 20 ampere. So the current 20 ampere will flow here. At this point the current will be diverted. The current will divert here. Here 5 ohm is available. So these two are connected in series. So 2 plus 3, this is also 5 ohm. The current will not go to the open circuit. The current will go to this 5 ohm resistor and remaining will go to this 2 ohm and 3 ohm. That is total of 5 ohm resistor. Both are equal. This is 5 ohm. This is also 5 ohm. So current will be equally divided. 10 ampere and 10 ampere. Total 20 ampere. 10 ampere flow through this 5 ohm resistor. Remaining 10 ampere will flow through this 2 plus 3 5 ohm resistor. Right? So the equal amount of current will flow in the both the branch. Now we got the value of current flowing through this 3 ohm resistor. So V Thevenin, that is VAB, is nothing but voltage drop across this 3 ohm. Right? So V Thevenin equal to VAB, that is nothing but voltage drop across 3 ohm. Both are parallel. So that by finding the voltage drop across 3 ohm, we can easily find the VAB or VTH. Right? So V equal to I into R. I is 10 ampere. R is 3. So minus, it is going down. So minus. So minus 30 voltage. So the voltage across 3 ohm is 30 voltage. That is VAB, that is VTH. Now we calculated the Thevenin voltage. Now we will find the Thevenin resistance, RTH. Right. What is RTH? The resistance across AB. We need to remove the voltage and current source. If you remove voltage source, that is short circuited. If you remove current source, it is open circuited. You have to keep the circuit in open condition. If it is current source, open circuit, voltage source means short circuit. So here we have current source, so it is open circuited. We need to find what is the resistance across AB. So current will flow through this. At this point, the current is diverted. So we need to follow from this side onwards, not from this side, not from source side, from load side. That is the RAB is the R Thevenin. So we have to follow from this load end. So current is diverted here. So this 3 ohm and here 2 and 5 ohm is there. Current will not go to open circuit. So that 2 plus 5 ohm are connected in series. That is connected in parallel with the 3 ohm, right? So current is divided in these 2 branches. So these 2 branches are parallel, 3 ohm. Here another 5 ohm is there. So both are same amount of current is flowing through 2 ohm and 5 ohm. Current will not go to open circuit. So 2 plus 5, 7 ohm is one resistor and 3 ohm another resistor. Both are connected in parallel. So the R Thevenin equal to this parallel combination is nothing but R Thevenin. R1 into R2 divided by R1 plus R2. So 3 into 7 divided by 3 plus 7. 21 divided by 10, that is 2.1 ohm. Right? So the Thevenin resistance is 2.1 ohm. This Thevenin resistance is nothing but internal resistance of the circuit. Right? Now we'll go to the next one. So we calculated the Thevenin resistance and Thevenin voltage, that based on according to the statement of maximum power transfer theorem, the value of R for maximum power transfer to is RTH. We already discussed that the load resistance equal to internal resistance. Internal resistance we calculated 2.1 ohm. RTH is 2.1 ohm. Right? So the same value is applicable for load resistance. Load resistance also 2.1 ohm. So that only we are calculating Thevenin equivalent circuit. Thevenin equivalent circuit contain VTH and RTH. That RTH is nothing but internal resistance. Based on maximum power transfer theorem, internal resistance equal to load resistance. Right? So internal resistance is 2.1 and load resistance also 2.1. So under that condition, the maximum power transfer, we have formula is available. Right? The details about maximum power transfer theorem explanation available in separate video. So this is the formula, V square TH divided by 4RL. Right? RL value is 2.1 ohm. So that is also one of the question. RL value is 2.1 ohm. The maximum power transfer, we have formula is available. Right? Thevenin voltage we already calculated. So VTH divided by 4 into RTH. Both are equal. RL equal to RTH. So V Thevenin is minus 30 square divided by 4 into R Thevenin is 2.1 ohm. So by simplifying we got 107 watts. So this is the maximum power delivered to the load. So in this we need to calculate two parameters. One is maximum power delivered to the load and the load resistance. Load resistance is nothing but 2.1 ohm because load resistance and Thevenin resistance both are equal. So that we are calculated V Thevenin and R Thevenin. So in this problem we use the maximum power transfer theorem. We calculated the value of load resistance and maximum power delivered to the load resistance. For that we use the Thevenin equivalent circuit, V Thevenin and R Thevenin. R Thevenin is nothing but is equal to load resistance based on the statement of the maximum power transfer theorem. This V Thevenin we can use for finding the maximum power delivered to the load, V Thevenin and R Thevenin. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.